Welcome back, everyone. Today we're going to be talking about the quotient rule and where it comes from. There's a couple of ways to prove it. There's one where it involves the difference quotient and a bunch of algebra, but the much nicer way is by using everything that I've talked about before, the product rule, the power rule, and the chain rule, all together to come up with the quotient rule. Now, the quotient rule looks like this. The derivative of f of x over g of x is equal to f prime of x times g of x minus f of x times g prime of x all over g of x squared. Now, why is it this order of minus? Why is the denominator squared? Where the heck is this all coming from? And that's what we're going to be talking about. The first step is breaking it up from a quotient to a product. Instead of thinking about it like division, we're going to think about it as multiplying f of x by 1 over g of x. And then we also see that this is equal to f of x times g of x to the negative 1. And this is the expression we're going to take the derivative of. The first step is very simple. We're going to take the derivative of the first function and multiply it by the second function. And then after, we're going to be multiplying the derivative of this function, this whole thing, times f of x. And that's just the product rule. So the first part of it is going to be f prime of x times this expression, g of x to the negative 1. But this next part is going to mean we're going to have to take the derivative of this expression. And how do we do that? Well, we're going to have to be employing the chain rule. We see that given a function h of x is equal to x to the negative 1, this expression right here is h of g of x. And so to take the derivative of that, we're going to get h prime of g of x and then times g prime of x. And this is by the chain rule. Now, h prime of g of x is going to be employing the power rule. We're going to bring the negative 1 to the front, and then we're going to have negative 2, except our input is g of x. So we're going to have negative g of x to the negative 2, and then multiplied by g prime of x. And of course, g of x is just a general function, so it's just going to be times g prime of x. Now, bringing that expression down and multiplying by the f of x from here, we see that our full product rule expansion will look like this. Now let's rewrite this back into terms of quotients. What we get is this new expression, f prime of x over g of x minus f of x times g prime of x over g of x squared. Now, since we're subtracting, we need to multiply this left fraction by g of x over g of x in order to equalize the denominators. And we're going to get f prime of x times g of x. And now these denominators will be the same, g of x squared. So we can just minus f of x times g prime of x all over this common denominator of g of x squared. And of course, our original expression was finding the derivative of f of x over g of x. So we see that the quotient rule will get us the derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared. So it's a little bit of a rearranging of the algebra and employing all of the rules that we've talked about thus far, being the chain, product, and power rules. Hopefully that explanation made sense, and thank you so much for watching.